Now let's take a look at identifying multiples and applying different divisibility tests. So what are multiples? Well, multiples, if you'll recall, are basically products of a counting number and any whole number that you can think of. So you can see the list here of multiples. We have multiples of 2, where you multiply the value 2 by all of the counting numbers. So 2 times 1 gives me 2, 2 times 2 gives me 4, 2 times 3 gives me 6, so on and so forth, right? Now this works in reverse as well. So we could think of multiples and divisibility tests as really leaning into the same topic, right? So multiples, again, suggest that we're multiplying some original number, some counting number, by whatever we're interested in. And that product gives us the list of multiples that you see here. So what is the multiple of a number? Well, it's another way of talking about what we just mentioned, that product of a counting number and who cares what the number is in, let's say, giving it a generic value this way. And so divisibility plays into this because it is the other side of that coin. If a number is a multiple of what we just chose, then it's got to be divisible by that value. So another way to say that 15 is a multiple of 3, right? Because 3 times 5 gives me 15, is to say that 15 is divisible by 3, right? So when we divide 3 into 15, we get a counting number. So 15 divided by 3 has a relationship to 5 times 3 equaling 15. And that's the whole point of understanding the divisibility rules. They allow us to break down numbers more quickly by understanding this relationship. So let's look at our different divisibility rules. So we have rules for 2, 3, 5, 6, and 10. Now in this class without a calculator, it's really important that you understand these because it helps you break down more quickly larger values. That's the entire trick of this class, understanding how to take an intimidating number and break it down into smaller bites. So here's how we can do that. Identifying the very first value here, we're interested in learning about the rule for 2, an even number, right? If the last digit of whatever we're interested in finding divisibility rules for is even, meaning it ends in 0, 2, 4, 6, or 8, I mean those are the only options for the last digit, then we can say it's even, therefore it's divisible by 2. This is a really easy one to remember, and most of you probably already have it memorized. The other two that I would say are most easily remembered are the rules for divisibility by 5 and 10. For 5, if the last digit is either 0 or 5, then it's divisible by 5. And for 10, if the last digit is 0, then it's divisible by 10. Now the other interesting one here is divisibility by 6. If a number is both ending in an even digit and, for the rule of 3, the sum of the digits is divisible by 3, then we can say it's also going to be divisible by 6. Now, the ones that I think you'll use most often are the rule for 2 and probably 5 or 10. The sum of the digits being divisible by 3 is one that most people forget, but it's actually often really helpful to start with just these first few values or these first few rules to see if you can break your number down more quickly. So let's look at an example here. We're asked, is 5,625 divisible by the following numbers? 2, 3, 5, 6, and 10. So let's look at our rules again. Well, the last digit here is 5. Well, that automatically shows me that it's going to be divisible by 5, right? Now, the last digit actually is not even, so we can go ahead and kick out 2. And if we can kick out 2, we must also be able to kick out 6. And looking at our other rules here, it does not end in 0, so we can kick out 10. The last one we have to consider is if the sum of the digits is divisible by 3. So let's look at the sum of the digits. My digits are 5, 6, 2, and 5 again, right? So 5 plus 6 is 11, plus 2 is 13, plus 5 is 18. Now 18 is actually going to be divisible by 3. And in fact, looking at the chart that we saw earlier, something like 3 times 6 would get me there. And so we could say that yes, in fact, it is divisible by both 3 and 5. So if we're interested in breaking this number down, 5,625, we could do so by dividing the entire digit by 3 or 5. Here's another set of questions. See if you can figure this one out for yourself. Determine whether 4,962 is divisible by one of our following digits. Focusing in on the first question here alone, we can say that the last digit is in fact even, therefore we can consider the value 2 as something that would work. Now let's look at the last couple of examples here. We say if it ends in 0, well, it does not. We can count that one out. It doesn't end in 0 or 5, and we can also count that one out. So let's look at our digits again. The sum of the digits here, we have 4 and 9 and 6 with 2. So together we get 4 plus 9 is 13, plus 6 is 19, and then plus 2 gives me 21. Sure enough, another number that is divisible by 3. We could say something like 3 times 7 proves that this outcome is accurate. Therefore, we could say 3 also works for the divisibility rule. Now, you can see that we've got 2 and 3 checked off. We have to also include 6, which means this value, 4,962, has at least 3 digits that we could use to break it down into smaller numbers.